Hello students, the question is, figure shows a rectangular current carrying loop placed 2 cm away from an infinitely long straight current carrying wire. The magnitude of net force acting on the loop is option 1 7.8 into 10 to the power 4 newtons, option 2 7.8 into 10 to the power minus 4 newtons, option 3 9.4 into 10 to the power minus 4 newtons, and option 4 1.6 into 10 to the power minus 4 newton. So the problem is based on the topic magnetism, and in particular the force between two current carrying wires. Now the situation is this: there is a straight wire infinitely long, this xy, this is a segment of this wire. It is carrying a current of 25 amperes, and there is a loop, there is a current carrying loop, a rectangular loop placed at a certain distance from the long wire. Now this rectangular section, this particular side BC, is having a distance of 2 cm from this wire XY, and the segment AD, it is basically 12 cm from this wire, because this distance is 2, this is 10, so overall 12 cm. And we have to find out the net force acting on this particular loop. So first of all, we have to analyze that in the segment BC, the force is repulsive in nature. First of all, if you see that for this particular wire, the magnetic field, due to this particular wire, the magnetic field in this region, in the left hand side region where this rectangular loop is placed, is coming out from this plane of the board. To calculate the direction, to know the direction, we can use the right hand rule, this palm rule. First of all, place your thumb along the direction of current and the fingers pointing towards the region where we want to calculate the direction of the magnetic field. So if we place like this, then the direction of the magnetic field is outwards. And when the direction is outwards, from the formula F equals to I L cross B, we can find out the direction of the force on different segments. We also know that if two anti-parallel wires, anti-parallel means this is carrying current in the upward direction, this segment is carrying the current in downward direction, there is a force of repulsion. We know this rule, and we can also find out from this particular formula that the direction of the force is basically in this direction. It means that it's a repulsive force. Similarly, for the AD segment of the wire, the direction sense of the current is same. So it means that this is the force which is attractive. This is the direction of the force which is attractive in nature. But there is a difference in these two forces magnitude wise, because the distance of this segment BC is close, whereas the distance of AD is a bit large. It is 12 cm, and this segment BC is 2 cm away from the infinitely long wire. Now the segments AB and DC, they also experience a force, but the force on these two segments are in such a manner that their magnitude is same, because if we take different segments of these wires, AB and DC respectively, then the distance is same. For example, we take this segment, small segment, we take this small segment, then the distance is same, and we can find out some different segments which are matching in terms of distance. In other words, we can say that the magnitude of the force acting on these two wires is same, but the direction is, for the AB segment it is downwards, and for the DC segment it is upwards. So these two forces cancel each other because they are magnitude wise same, but the direction wise opposite in nature. We can find out the direction by the vector rules or some other rules also given in text. According to the vector rules, L cross B, so if we calculate L cross B, the direction of the force comes out to be in this direction. And for this segment DC, the direction of force is in upward direction. So these two forces cancel each other. So we need not to calculate the force acting on the AB and DC section of the wire. Now we have to calculate the force on the BC and the AD section of the wire. Now let us calculate them. First of all, on the BC segment of the wire, the force acting on the BC segment of the wire is given by mu naught upon 4 pi 2 times I1 I2 upon the distance. For example, this distance is R1 times the length of this segment BC, the length BC. So this is the formula to calculate. Now putting the respective values, mu naught upon 4 pi is 10 to the power minus 7, then 2 into I1 into I2 means 15 multiplied by 25, 15 multiplied by 25, and then multiplied by the segment, this segment BC, its length is 25 centimeter. In terms of meter, we can write it as 0.25 upon R1. R1 is this distance, so this is 0.02 meters. So in this way, we get this particular ratio, and it comes out to be, after solving it, it comes out to be 9.375 into 10 to the power minus 4 newtons. This is the value of this particular expression, this calculation. Now similarly, we can find out the force on AD segment of the wire. So FAD is mu naught upon 4 pi into 2 times I1 I2 upon R1 multiplied by the length of this segment AD. Now putting the respective values in a similar manner as we have done for FBC. So this value comes out to be nearly equal to, this comes out to be 1.56, nearly 1.5625 into 10 raised to the power minus 4 newtons. So this is the exact value. Now we know that we can easily see that the magnitude of FBC is more as compared to FAD. It means that the net force is repulsive in nature. So F net, we have to calculate F net. So F net is basically FBC minus FAD. Now solving it by subtracting it from this to this, we get this value nearly equal to 7.8. This comes out to be 7.8 into 10 raised to the power minus 4 newtons. So we can say that option 2 is correct here. This is the final result. तो यहाँ में एक प्रॉब्लम दी गई है, इसमें कहा गया है कि एक स्ट्रेट वायर है, इनफाइनेटली लॉन्ग वायर है, 25 एम्पियर की करंट कैरी कर रहा है, उसके नियर अबाउट एक रेक्टेंगुलर लूप प्लेस किया गया है, उस लूप में 15 एम्पियर की करंट फ्लो हो रही है, उसके ऊपर लगने वाले नेट फोर्स की वैल्यू पूछी गई है. तो यहाँ पे सबसे पहले हमने एनालाइज किया कि AB और DC सेगमेंट्स पे जो फोर्स होगा वो एग्जैक्टली अपोजिट इन नेचर एंड इक्वल इन मैग्नीट्यूड होगा. तो ये दोनों फोर्सेस एक दूसरे को कैंसल आउट कर देंगे. फिर हमने BC पे लगने वाले, BC सेगमेंट के ऊपर लगने वाले फोर्स को एनालाइज किया. सबसे पहले रिपल्सिव नेचर का फोर्स होगा और साथ ही साथ इसका जो मैग्नीट्यूड हम कैलकुलेट करेंगे वो इस फॉर्मूले की हेल्प से कैलकुलेट करेंगे. म्यू नॉट अपॉन 4 पाई 2I1 I2 अपॉन R इंटू द लेंथ ऑफ दिस सेगमेंट BC. सारी वैल्यूज पुट करने के बाद, प्रॉपर SI यूनिट में कन्वर्जन के बाद, हमें जो फाइनल इसकी वैल्यू मिलती है वो आती है 9.375 इंटू 10 पावर माइनस 4 न्यूटन्स. इसी तरह से हम AD सेगमेंट ऑफ द वायर के लिए भी कैलकुलेशंस करेंगे, जो ये वैल्यू निकल के आती है 1.5625 इंटू 10 पावर माइनस 4 न्यूटन्स. यहाँ पे हम साफ साफ देख सकते हैं कि जो रिपल्सिव फोर्स है उसका मैग्नीट्यूड ज़्यादा है एज कम्पेयर टू द अट्रैक्टिव फोर्स. AD जो है वो एक तरीके का अट्रैक्टिव फोर्स है और BC पे लगने वाला जो फोर्स है वो रिपल्सिव फोर्स है. तो यहाँ पर रिपल्सिव फोर्स का मैग्नीट्यूड ज़्यादा है, तो इसमें से अट्रैक्टिव फोर्स वाले मैग्नीट्यूड को सब्ट्रैक्ट करेंगे तो हमारा जो रिजल्ट नियरली आता है 7.8 इंटू 10 पावर माइनस 4 न्यूटन्स के आसपास, यानी ऑप्शन सेकंड हमारा करेक्ट होगा. So this is the whole explanation of the problem. Hope you understand it. Thank you.